All right, hello everyone. I am Dr. Joby Hilliker, and I have my colleague with me, Shannon Hilliker, who will introduce herself in just a couple of seconds. Thank you so much for coming on to our presentation for NSTA Engage Fall of 2020. We'll be with you the next 35 minutes or so, and the title of our presentation is a problem-based learning, PBL, in meteorology using an online severe weather events archive. Now, just a little bit about ourselves. I am an associate professor of meteorology at Westchester University. I've been there for just over 15 years now. There in the Department of Earth and Space Sciences. Shannon, I'll give you a couple minutes.
And my name is Dr. Shannon Hilliker, and I'm an assistant professor of TESOL in the Department of Teaching, Learning, and Educational Leadership at Binghamton University, and I've been in this role for about 5 years. And so we're going to talk to you today about our PBL, and here's an outline of what our presentation will look like. First, just a review of problem-based learning and PBLs in meteorology. And then an overview of the specific PBL. And then I'm going to turn it over to Joby, and he's going to talk about the implementation in the classroom and the PBL activities there. And then I'm going to come back and do an assessment, talk about the student assessment we did of this PBL, and then finally a summary of our presentation. And so just a review of problem-based learning. In general, there are many tenets of it that are found in the literature, and basically students work collaboratively to answer open-ended questions devised by the instructor in a series of steps that leads them to acquiring new knowledge associated with their coursework. And so PBLs in meteorology, it's one branch of science that really lends itself to having PBLs in the classroom. And the reason why is because there's a big emphasis on case studies, and there's lots of value in infusing current cases into the curriculum. And so there's data collection, which can foster analysis and computer literacy and technology use, which supports 21st century skills for the students. There's a bonus that many of these case studies are accessible on online databases now, and that can be especially important nowadays, especially in our global pandemic, because this can be still used in distance and virtual classrooms. So that's something to think about in education where we are right at the moment. PBLs in meteorology specifically, the use of PBLs in meteorology education in the literature is fairly limited. You see a few of them listed here. I just want to sort of highlight the last one in 2015. These authors shared a PBL where emergency workers plan for severe weather. This one has similar real-world application in that the students get experience with prediction of severe weather and the ingredients for that severe weather. And so the purpose of our presentation is to show you as practitioners an additional option that has been conducted in Joby's course for over a decade. And so the overview of this PBL in Joby's course wants students to answer the research question, what atmospheric conditions lead to tornadoes, hail, and damaging winds locally? And so students work together in weekly activities to collect and analyze data for severe weather. And you see here on this slide, it's a case study approach using this online database from the Storm Prediction Center. That's a screenshot of it here, and Joby's gonna bring it a little bit more live to you so you can see it. And so it catalogs severe weather events, and there are maps and analysis of weather conditions of severe weather for each day across the United States, and it monitors things such as wind gusts. And so in this PBL, there was a series of activities where students are working together using technology. And of course, nowadays they can use more or less technology depending on how distant the students are from you or each other. And using their interpersonal skills, they negotiate during this data collection. And then the third part, at the end of the semester, students construct an oral presentation and a written manuscript that reveals frequently occurring severe weather atmospheric ingredients with threshold values indicated. Things such as tornado, hail, and wind. So the qualitative values are those that appear most frequently, and students are asked to modify those thresholds and with respect to the severe weather type for the quantitative part. And it should become evident that there are favorable parameters, and students are challenged to provide a hypothesis as to what caused severe weather. And so the last thing in the overview of this PBL is it's suitable for secondary and post-secondary students. But something fairly important is students should already have some prerequisite knowledge, such as atmospheric stability, the jet stream, and the mid-latitude cyclone. And the American Meteorological Society is an excellent resource for definitions and physical descriptors for these variables, including what they reveal about the atmosphere. So now I'm going to turn it over to Joby, and he's going to talk specifically about the project in his class.
Good, very nice. Thank you, Shannon. So moving on to in the implementation stage, typically what you want to do, or what I do in my class, is I have about 10 or 20 students, and I pair them up. And you can see I have a picture from a group of students, or a pair of students from, they had the year 2014 in which they analyzed. I think student pairs, obviously, there's some advantages there. Obviously, it creates some mutually beneficial relationships. They can exchange their background. Maybe they have some prior experience in data analysis or collection as well. And also this database, it goes back to 2000, so you have about 20 years to work with. That should not be a problem. But pairing them up does make the workload, I think, a little bit manageable, not only for the students, but also for the professor or instructor as well. And once you form student pairs, what you want to do is assign each pair a different year. And if you have, let's say, 7 pairs, you can just simply go back 7 years. Some years are a little bit more exciting than others, but you do want to pick a suite of years that certainly have impactful severe weather events. Okay, and now for the meat and potatoes, the actual activities. And I would like to share with you 5 activities that we've constructed for this PBL. Each activity takes a few hours to complete. One strategy that you can use in your classroom is you can use the lecture portion to convey knowledge or additional knowledge, such as some of the severe weather parameters, positive vorticity advection, what a trough is, maybe some of the more intermediate or advanced meteorology concepts that you may see here in these activities. One thing I do want to stress is there is a artifact, there's a student artifact, which is basically going to be a completed data table that the students will need to complete. So what I do, and this is certainly very common, is as students are engaging with each other in terms of just looking at the data collection and analysis, I roam around, I ask questions, I just make sure that this table is being completed, and of course it's being completed accurately. I always give like a thumbs up or a check after the students complete the artifact and then move on to the next activity. So there are 5 activities. The first one is pretty simple. They need to identify a subset of cases. And the middle part, activities 2 through 4, that is the crux of the PBL, where they're going to do some data collection. And then finally, they're going to wrap it up. And we have, of course, Bloom's taxonomy, with the synthesis data, kind of bringing all the data together into one. And then, of course, they're going to answer some evaluation questions, things that they've learned about the atmosphere. Okay, so here is the first activity. And basically what students are going to do is just look at their year and look at their state. We're from basically Pennsylvania, so I asked students to look at Pennsylvania. And the goal here is to come up with the top 5 events. Each event is a row, or a column rather. And there's going to be some information that we would like, and those are going to be found in the rows. So what I want to do now is actually go through this live and give you a chance to look at this SPC website. So what I'm going to do is switch gears, and I'm going to share the SPC website. And there it is. It's the Severe Weather Events Archive. By the way, the SPC stands for the Storm Prediction Center. They're the fine folks that look at chances for severe weather across the United States, basically every day. You're familiar with tornado watches and severe thunderstorm watches. These are the folks that issue the watches, and they do a great job. Very busy during the summertime, not so much during the wintertime. Now, I'm going to share with you the website. By the way, a kind of a quicker way to actually access this website is just do a Google search on severe weather events, SPC, in case the actual URL address changes over the next couple of years. Really user-friendly, and you know, it's going to take probably a little bit of a learning curve, like everything does, both for the practitioner and the students. I always like to give kind of a practice exercise so that students can feel comfortable with the database before they dig in. But this is what it looks like, and it is a continually updated and also searchable online archive. And what I'm going to do is I'm going to choose last year, 2019, and I'm also going to choose the state. So these are the parameters that I'm going to enter, and then I'm going to hit Retrieve Events. And voila, these are the dates in 2019 in which there was at least one severe weather report. Severe weather either being a tornado, hail, or a wind gust more than 58 knots. And you can see Pennsylvania is lit up. So the goal is for students in activity number 1 to choose the 5 most impactful events for the region. There's a lot. I think one suggestion I can convey is to take a look at the total number of reports, and that's denoted by these numbers in the middle. So as an example, Halloween of last year, there were over 300 reports of wind across the United States, so pretty active day. So once you click on a day, each day looks identical to this, obviously with just different data, and you get a map, and this map is really beneficial because it gives you the big picture, the scope of the severe weather. Blue, by the way, represents a severe weather or severe wind report. Green, which actually we did not have any hail in October, and none listed, so no green. And then you notice there's a couple of reds, and red actually represents a tornado. So here in Pennsylvania, it was quite an active day, and to me, I would put this as a contender or a candidate for one of the top 5 events. Okay. Now, once the students feel, you know what, this is a pretty impactful event for the region, that this should be in our subset of the top 5 events, detailed reports are then found below. And what I like to do is just scroll through. Obviously, on this day, we had a lot. And eventually, you'll get to Pennsylvania. Okay, so these are basically arranged chronologically. And on this particular day, we had our severe weather occur later in the evening. And once we are right about here, you notice now we have more in the way of Pennsylvania. These are counties, by the way, so Berks County, Chester County, which is located actually in Westchester University. So it looks like we have some information about when exactly the severe weather occurred. And also we have some description, trees down, the strength of the tornado. So you're trying to get a little bit more information about the event. All right, let me go back to my PowerPoint. And now that we have October 31st as being a key event, what we can do now is put that information in. Okay, so in this case, I'm asking for the time, how many tornadoes, how many wind, just for the student to feel a little bit more familiar with the event. And this is what a student actually wrote down for 2019. So in this case, we had a lot of summer events, as you might expect. A lot of them occurring in the afternoon. You do want to know what UTC is. UTC is Z time, which is about 4 hours ahead of Eastern time. And then you notice that many of the events had tornadoes, many had hail, not all. And then of course, we got the wind there. So this is a deliverable for activity number 1. Now, if this were live with you, we would then spend probably the next 5 or 10 minutes asking you to go on the website and find your own event for 2019 based on the state. By the way, if you're on the West Coast, you probably know that severe weather is not too often, so you may want to pick a different state like Oklahoma or someplace in the Great Plains. But so for homework, if we can give you homework, we want you to go to the website and just play around with the website and identify an additional severe weather date for 2019 for your state, and then just scroll down and review some of the information in the reports. So good luck with that. Okay, moving on. 2 through 4, so each of these is a different activity which requires a week or 2 of time. And what I did was I focused on each of the different data types. So number 2 is the surface data, the one that's probably most accessible to the practitioner and students. Then we take it upstairs to 300 millibars, upper level maps, the jet stream troughs, that's number 3. And then the last one is your radiosonde data, which are these weather balloons, which I'm sure you know get released twice a day as well. So this is what the table looks like for activity number 2. And by the way, if you're interested in seeing these tables, just email me or Shannon. We'll be happy to provide you the paper versions or the hard copy versions. Just because of presentation, we needed to remove some of the finer detail with actually what you see here. But one thing we do want to emphasize, they're all going to look very similar to this, where each of the cases are found in the columns. And then we have the severe weather variables in the row. Okay, some of them are going to be qualitative, like proximity of front, and some of them are going to be quantitative, like dew point. Okay, so what I want to do is then go back to the SPC website, and I'm going to now show you how to access the surface data. So we're back here, and the way that it actually works out, which is really nice and logical, is that the surface data is found here. The upper level data is found in the next section. So this is with activity number 3. And the sounding data is found here in activity number 4. So let's go back to activity number 2. So I'm going to click on OBS and mesoanalysis. A lot of information. If you want to do radar data, you're more than welcome to perhaps even make an additional activity for the students. And you want to go to basic overview, and it's found here under something called HPC surface analysis. And if you click on this, this shows the surface map, and I'm using also the one from our date that we deemed to be a pretty significant event, October 31st. I'm going to fast forward to 3Z, which is, if you remember that most of the severe weather, at least in Southeast PA, occurred around 2Z. So this is a surface map that is closest, that is coincident with the time of the severe weather. And man, what a beautiful, strong mid-latitude cyclone right there, 990 millibars. We had a cold front, very strong cold front. So I'm not generally surprised that this would be conducive for severe weather. So what students are going to do is they're going to retrieve some of these severe weather parameters like proximity to the cold front, pressure of the mid-latitude cyclone, and the dew point from the surface map. All right. So we're going to fast forward, and this is what the Activity 2 table could look like from 2019 for Pennsylvania. So my October 31st case is over here. One thing I do want to mention, Larco's Triangle, if you're familiar with Larco's Triangle, that's always an indicator of tornado location. And you notice here, there's one case in which we had no tornado, so you just want to exit out, not include it in the database. So for the final step, after the data collection, what students are going to do for each of these activities is they're going to shade in, or what I've done here was I've highlighted with a box with an outline around the cell. Those cells or those parameters, those variables that are conducive for severe weather. So for example, dew point, it's known in meteorology that if the dew point's greater than 65, it's conducive for severe weather. And in each of the 5 cases, we in fact had a dew point greater than 65. So it gets shaded in. Likewise, if there's a mid-latitude cyclone, it's well known, low pressure, convergence, rising motion. So again, they get the shade, okay? Now, I specifically include in the tables that we have a little bit more detailed information that kind of guides students. It will say in the table, shade if, and there's a condition to kind of better guide them. All right, so if you're up for more homework, what we want you to do is go back to the SPC website, and for the case that you've identified from activity number 1, we just want you to assess the surface map. See if there's a mid-latitude cyclone, see if there's a cold front, things like that. Okay, because of time, we just want to show you the completed artifacts for activities 3 and 4. This is what the upper level table would look like. And notice that we have different qualitative and quantitative parameters. If you know anything about severe weather, you do need a strong trough, is always conducive. An upper level divergent signature, kind of like the fanning of the height lines, also fosters upward motion. So if you have a yes, shade it in. And then finally, this is what the sounding data look like, the table. And this one's just a little bit different. Aside from the data type, you notice that it is all quantitative variables as well. So a lot of numbers, a lot of data. And once again, if there are certain thresholds that are met, and these thresholds, by the way, are accepted threshold values that we've kind of empirically learned over the years, yeah, then you want to say, hey, this is certainly the case for Pennsylvania. So for example, LI, if the LI is negative, Lipton index, that's an unstable atmosphere, and that's the case for all of our 5 cases in 2019. Okay, so you want to fast forward several hours of work, perhaps several weeks in the class. You're now towards the end of the semester, and finally, you got the data synthesis. This is actually divided into 2 parts, activity number 5. So there's two tables, 2 artifacts. More or less, you're going to do the same thing with each of the tables. The first one that you're going to do is the students are then going to look back at all the data that they collected. And what I've done here was I've listed the parameters that you remember from activities, at least from 1, 2, and 3. And what students are going to do is they're going to respond with the percentage of events that possessed each severe weather variable. In other words, there was a check. They shaded it in. And at least for our case in 2019 for Pennsylvania, this was the result. So one thing that's really interesting is that all the cases, all 5 cases, had a mid-latitude cyclone. All the cases had a front. Most of the cases had that upper level divergent signature. And then some of the cases, 2 or 3, had kind of a hodgepodge of some of the other severe weather variables. So again, the students are trying to extract those severe weather parameters that were found most frequently from their analysis. So beautiful, beautiful synthesis stage for the activity. And then finally, the second part of activity number 5, you're playing the same game, but now you're going to focus on the quantitative variables. So remember, as Shannon mentioned, we have qualitative variables, we have quantitative variables. So what I've done here was I've listed the quantitative variables, and I've reminded everybody the accepted threshold values. And once again, students are going to look back to their previous activities, 2 through 4, and they're going to write down the percentage of events that exceeded those approved threshold values. And what a result here. It looked like in 2019, we had all 5 cases had a jet stream. We had a very strong jet stream. We had a moist atmosphere. We had an unstable atmosphere, which are generally key ingredients that you need for severe weather. Now, finally, this is an option to you. One of the things that we also like to do is ask the question, do you want to tweak? Should you revise the threshold values? It's well known that a dew point greater than 65 is conducive, you get a lot of moisture, so that's conducive to thunderstorms and severe thunderstorms. And what this allows to do is answer the question, perhaps tailor the severe weather thresholds just for southeastern Pennsylvania. So in this case, we actually had all 5 cases even higher, greater than 66 degrees Fahrenheit. So I thought this would be a fun activity because then you can share these revised threshold values to your local National Weather Service office to kind of hone in on your particular location. Okay, so we have the data collection, we have the data synthesis, we have an idea of our threshold values, which variables are most conducive for severe weather. Those questions can now be explicitly answered in these evaluation questions. And I think this is a really important step because students will share the results, as Shannon mentioned in the oral presentation and manuscript. Question number 3 is a really interesting question because it answers the big picture. What is one thing you learned about atmospheric behavior as a result of this project? And this is a response. This was actually me trying to be a student. And I think one of the goals that I hope the practitioner can retrieve from this PBL is that besides that, the fact that the atmosphere is awesome is that, you know, there are minimal conditions necessary for severe weather to occur, but, you know, not all the variables are going to light up. You know, on this day, some are going to be lit up or shaded, and on a different day, you may have different variables now coming to the forefront. So every day is unique, so the conditions vary from day to day, and that's what makes the atmosphere complex. Hopefully students realize that we, you know, even though we try to forecast, we still have a lot to learn. The atmosphere is certainly nonlinear, so once you think you've kind of understood the atmosphere, something else, some combination of antecedent conditions become necessary. So that's always a fun question, I think a really instructive question for the students. All right. So now I'm going to turn it back to Shannon, and she's now going to talk about the assessment. What's the impact of this PBL on students?
Thank you, Joby. Okay, now that you've heard about all of the activities that he works through with his meteorology students in his classroom, of course, as instructors, we want to know that this PBL had an effect on our students. And so we looked at that in 2 parts. The first part is the effective attitude they have towards the PBL components, and then the second part is the knowledge of severe weather ingredients that they have after this, before and after this. And students were asked open-ended questions to list those ingredients that generate severe weather. And so in Joby's class in the spring of 2020, 5 students volunteered in an IRB study that we conducted, approved by the IRB, and they answered an identical set of pre and post PBL questions. So this is an indirect assessment, and part 1 assesses their comfort and experience on a 4-point Likert scale of 3 components of the PBL, which was writing, oral presentation, data collection, and data analysis. And you can see here, we have a chart of the mean pre and post survey response scores. Most of the students' attitudes towards the PBL components increased in general. However, because there are only 5 students, it was tough to get statistical significance. But even with the small sample size, there were 3 statistically significant parts of this, and you can see them highlighted in blue. They are writing comfort, oral presentation comfort, and oral presentation experience. This PBL focused on meteorology as something you might want to consider in your classroom because students got this practical and transferable skills that can serve them in their other classes as well as hopefully in their employment in the future. And so, again, the second part was given to those same 5 students, an identical set of pre and post PBL questions, and another indirect assessment where students were asked to list the atmospheric ingredients conducive for severe weather, which are, as you heard Joby mention several times, tornadoes, hail, and damaging winds. And this table compares the pre and post PBL distribution of student responses when they were asked to identify those factors. So in the pre-survey, students could correctly identify several key weather ingredients based on their recall of the meteorology training they had had in their introductory courses. In the post-survey, students were able to expand upon the list of those conditions. And most apparent to us was their ability to identify several additional processes that cause rising motion in the atmosphere. And so students' knowledge of severe weather causes increased, and they were able to expand various measures of atmospheric stability and specify for each measure the thresholds that were favorable for severe weather. Mm-hmm. So now I'm going to turn it back over to Joby for a summary of our project.
Yeah, thank you. So yeah, Shannon, those results were encouraging. Like I said, 5 students, not the greatest, but at least ultimately the goal is we want to share this and have you consider such a PBL in your class. What's great is it could be modified to whatever severe weather variables you're comfortable with. So if you're starting out in a meteorology course, you may not want to do more of the immediate or advanced concepts. Totally up to you. In terms of which variables you want to kind of drive at or emphasize in your class. So hopefully you can get a sense of what we're trying to share. We think it has huge practical implications. Obviously, students love severe weather. Who doesn't love severe weather? And unfortunately, as you know, it's hugely critical when it comes to accurate forecasts, not only in terms of protecting life, but also protecting property as well. Again, having this online severe weather database, I think this is really conducive, particularly in a situation where you're teaching an online course. You could just simply send the tables remotely and just have students work. So I think that works in this particular setting. And ultimately, we want students to better understand those atmospheric conditions, the antecedent conditions that lead to severe weather. So they can become a little bit more knowledgeable on how the atmosphere works. And we think it's a really fun PBL for you and the students. So with that, we're going to close. We thank you so much for bearing with us the last 35 minutes or so. Once again, I'm Dr. Joby Hilliker, and I thank my education colleague, Dr. Shannon Hilliker, up there at Binghamton University. Quite a collaboration. And if you are interested in just talking to us, we're going to have that chat over the next 10 minutes or so. If not, feel free to email us, and we have those email addresses there on the screen. So thank you so much, and we wish you a good weekend.